So let's get started. What is a vector database? A vector database stores data as mathematical representations, and it facilitates memory of previous inputs for machine learning models. Some use cases could be searching things, giving recommendations, and even good for text generation. It works under the principle that it identifies data based on similarity rather than exact matches. Some practical examples we can think where this happens could be a salesperson suggesting similar shoes, or another customer bought something similar and a recommendation is powered by a machine learning model. This also enables the development of advanced AI programs like large language models. So now, what is a vector and how do vector databases work? Well, the definition of a vector is like an array of numerical values indicating the location of a point along multiple dimensions. You could think of it like a list of numbers, like 12, 13, 19, 8, 9. And the function of a vector database is that each vector corresponds to an object or item, like a word, an image, a video, a movie, or document. Vectors represent the location of each object along dozens or hundreds of dimensions. An example could be, in a movie vector database, dimensions might include running time, genre, release year, parental guidance rating, number of actors in common, and number of viewers in common. Accurately created vectors will result in similar movies being clustered together. I'll try to explain this in a visual representation. Let's say the x-axis of this graph is the study time, and the y-axis of this graph is a leisure time, and we're trying to find out what grade the student will get on the next test. Let's say we already stored 5 vectors in this database. Now let's choose a point on the graph. Let's say that the student studies for 6 hours, but has 4 hours of leisure time. What will be his grade on that next test? Well, what we can do is we can take the distance of the student from all the other points that are already stored in the vector database and see which one is closest. We will then take the closest point, and whatever value that closest point gives will probably be the value of what the student will have. In this case, maybe that close point was a B. So what are the uses of some vector databases? Well, it's really good at figuring out some similarities. So in applications, it can recommend similar products, suggest songs, movies, or shows, or suggest images and videos. In machine learning and deep learning, it connects relevant information to construct the complex machine learning and deep learning models. Another use could be for large language models. It enables contextual analysis of text, and it powers large language models like ChatGPT and Bard for natural language understanding and text generation. Another important topic is what are embeddings? Well, they are vectors generated by neural networks and used in vector databases for deep learning models. Neural networks can generate embeddings autonomously after fine-tuning. So lastly, that brings us to our point of what the advantages of using a vector database are. Well, first, it's efficient. Querying a machine learning model without a vector database is slow and costly, and machine learning models cannot remember beyond their training data and need context every single time. It's also cost effective. Repeatedly passing context to a model is expensive due to data movement and computing power. Most machine learning APIs have constraints on data acceptance limits. So what is the functionality of vector databases? Data goes through the model once, storing embeddings in the vector database, and it reduces processing time significantly. Some applications of vector databases, it enables semantic search, classification, and anomaly detection with fast results. Embeddings for queries are passed to the vector database, which returns similar pre-processed embeddings. Mappings back to the original content like URLs, images, or product SKUs.